Hi, this is Sonia Doucette. In this video, I'll show you how to calculate the amount of product produced by electrolysis given a current in amperes and a time over which that current was applied. The question you're being asked is a constant current of 30,000 amperes is passed through a molten mixture of NaCl and CaCl2 in a Downs cell for 1 hour. How many grams of sodium metal and chlorine gas are produced? A Downs cell is a specific type of electrolytic cell, and in this cell the reaction at the cathode is 2 sodium, and in liquid form, because we're dealing with molten sodium here, it occurs at very high temperatures, plus 2 electrons, giving you 2 sodiums without a charge in liquid form also. So this sodium is molten when it comes out of the Downs cell, but you can think of it as being cooled down to a solid. So that's the reaction that occurs at the cathode. At the anode, you have 2 chlorides, again in liquid form, going to chlorine gas plus 2 electrons. So these are the half reactions making up the overall redox reaction that occurs in this electrolytic cell. So to answer this question, the first thing you want to do is find the number of coulombs of charge that are passed through the cell. And one useful piece of information to know here is that a current of 1 ampere is equal to 1, or produces 1 coulomb of charge per second. So knowing this conversion, you can take that number of 30,000 amperes that you're given and equate that to 30,000 coulombs per second. And in order to get the charge passed through the cell over the given time period in coulombs, you take the time period you're given, which is 1 hour, and you convert that into seconds. So you have 60 minutes in 1 hour, and you have 60 seconds in 1 minute. So the minutes cancel, the hours cancel, the seconds cancel, and you're left with coulombs, which is what you want. So you have 1.08 times 10 to the 8th coulombs. The second step in this type of problem is to find the moles of electrons, because the amount of substance that's produced, which is what you're asked to find here, will depend on the moles of electrons. So moles of electrons is going to be equal to the coulombs, which you've already solved for, times 1 mole of electrons per 96,500 coulombs. And this number, 96,500 coulombs, is the Faraday Constant, which is the electric charge in coulombs on 1 mole of electrons. So the coulombs will cancel out here and give you what you want, which is moles of electrons. And in this case, we have 1,119.17 moles of electrons. The third step is to determine the half reaction stoichiometry to find grams of sodium metal produced. So looking back at the half reaction that's part of a Downs cell where sodium is relevant, the first one written up here, you can figure out this conversion of 2 moles of electrons to 2 moles of sodium metal produced. So 2 moles of electrons per 2 moles of sodium metal. So you can take that 1,119.17 moles of electrons and use this conversion where you have 2 moles of electrons for 2 moles of sodium. You're almost there, and you just need to use the molar mass to get to grams of sodium. So for every 1 mole of sodium, you have 23 grams of sodium. So moles will cancel, moles of electrons will cancel, and you'll be left with 3 times 10 to the 4th grams of sodium. So you've answered part of the question. You're also asked how many grams of chloride or chlorine gas are produced. So you do something similar here. And if you look back at the half reaction that's relevant to the production of chlorine gas, you see another stoichiometric relationship here in the half reaction that can help you convert the moles of electrons to grams of chlorine gas. And that is that you have 1 mole of chlorine gas for every 2 electrons. So 1 mole of chlorine equals 2 moles of electrons. So you take your moles of electrons again, 1,119.17 moles of electrons, and you use your conversion here, which is a little different than for sodium. So 2 moles of electrons for 1 mole of chlorine gas. Then you use your molar mass for chlorine gas to get 1 mole of chlorine gas per 70.9 grams of chlorine. So your moles of chlorine cancel, your moles of electrons cancel, and you're left with 4 times 10 to the 4th grams of chlorine gas. So you've answered the question about how many grams of sodium, metal, and chlorine gas will be produced when a current of 30,000 amperes is passed through a down cell for 1 hour.